Hello guys, welcome back to my channel. So we are looking the different continuation of this plumbing design theoretical part. So we have discussed so many topics. So we are on the turbulent and laminar flow. So there will be Reynolds number we have to calculate here. So there is one formula here for the Reynolds number, which is RE is equal to rho VD by sigma GC. Okay. So here is one question. You can see here the find the Reynolds number of 3-inch pipe. Okay. So there is 3-inch pipe which is in feet 0.25 at the rate of 4 feet per second. So you can uh, put this value in these formulas and you can find the Reynolds number. So in this question, the pipe dia is already given. Okay, so what you required, rho VD. So rho is the value of rho is already given here, 62.4, and V is nothing but the velocity, which is given here 4 feet per second, and D is nothing but the diameter of the pipe, which is given here 3 inch. So pipe in the feet, it should be 0.25 feet. Okay, and rho, the value of rho sigma is here 2.35 into 10 to the power minus 5. Okay, and GC should be 32.2. Okay, so put this value in this equation and you can calculate. This should be 82,500 Reynolds number. So that means which type of flow it is. So here you can see here the fully turbulent at Reynolds number greater than 10,000. So this is less than 10,000, that means not fully turbulent. And if the Reynolds number is greater than 3,000, the flow is a turbulent flow but not fully turbulent. Okay, so in our case the Reynolds number is 82,500. That means the water flowing through 3-inch pipe is turbulent flow, not fully turbulent. Okay, so next equation is Darcy formula. So from the Darcy formula we have to calculate the head loss. Okay, so here you can see the Darcy formula is HF is equal to 4 FLV squared divided by 2 GD, where HF is nothing but the head loss due to friction in meters. Small f is coefficient of friction, which is 0.007. L is the length of the pipe in meter. B is the velocity of flow in meter per second. G the acceleration due to gravity, 9.81 meter per second square. Okay, and small d is the diameter of the pipe in meter. So using this equation we have to calculate the head loss. Next equation is Hazen-Williams formulas. So Hazen-Williams formulas for designing a water supply pipeline flowing full under hydraulic pressure. Hazen-Williams formula is usually used. Okay, so here is the V is equal to 1.0955 into 10 to the power minus 4 into C into D to the power 0.63 into HF 0.54, where V is nothing but the velocity of the flow in meter per second, D is the diameter of the pipe in mm, HF is hydraulic gradient of friction loss of head in meter per 1000 meter. So 1000 per 1000 meter, what will be the friction loss? It's called HF. C is nothing but the coefficient depending upon the roughness of the pipe coefficient value, which is vary from 80 to 140, the coefficient of friction. Next equation is Chezy's formula. So Chezy formula is also derived in the same ways as a Darcy formula. So V is equal to CMI to the power 0.5, where C is a constant usually taken as 55. V is the velocity of the flow in meter per second, and M is a hydraulic mean depth. Cross-sectional area of the flow per length of the weld perimeter. I is the slope of fall. Next equation is Manning formula. So Manning formula, V is equal to 0.003968 d to the power 2 and 2 by 2/3 s to the power half divided by n, where V is the velocity of the flow in meter per second, is the diameter of the pipe in millimeter, S is the hydraulic gradient or slope of the pipe, N is the roughness or coefficient of pipe varying from 0.015 to 0.013. Okay, so here is some questions are given. So you can see here the question is calculate the head loss due to the friction in a pipe of 80 mm diameter, 400 meter length. Okay, and when the velocity of the flow of water through the pipe is 0.8 meter per second using Darcy formula, F is 0.007. So Darcy formula, HF is equal to 4FL squared 2GD. Okay, so put this value in this equation and you can find the head loss. So you can see here the F is already given here 0.007. L is nothing but the length of the pipe, which is given here already 400 meter. V is the velocity, which is also given 0.8 meter per second, and G is 9.8, and diameter of the pipe is also given here 80 mm. So you have to convert into meter. Using this value, put this value in this equation and calculate, you will find here 4.79 meter friction loss. Okay, next question is calculate the discharge through a pipe of 50 mm diameter lead for a length of 80 meter. When the head available is 3 meter, using Darcy formula, calculate the discharge. Okay, so we have to calculate the discharge. What will be the discharge using Darcy formula? F is already given, Q is equal to A into V. So using this is the discharge equation. So HF is the Darcy formula, so HF is 4FLV square by 2GD. From this equation you can find the velocity, and area you can see here the Q is equal to A into V. So V is already 1.15 meter per second, and A is nothing but the pi d square by 4, area of the cross sectional area of the pipe. So diameter is already given here 50 mm. So if you convert into the meter, 0.05. Okay, and a square of this value into pi divided by 4, you can calculate the discharge through the pipe, 2.26 liter per second. Q is equal to A into V. Okay, so HF you can find from using this HF, this formula you can find the velocity first, and then put this value in this equation, you can find the discharge. Okay, so the last this is not the last, there is 2 more questions should be go. Okay, and so these 2 questions we will discuss in the next topic, next video. So please be with me and keep watching my video. So thank you for watching my video. Thank you. Bye bye.